Welcome to everyone to our session about shaping the future of AI for conservation. This session is inspired by an event that we held in September in Oxford at the University of Oxford, sponsored by Schmidt Sciences. And we're really excited here today to hear from all of you. So we're going to give a little bit of our perspectives on a few different topics, sort of to do with AI for conservation. And then we would really love to kind of get a dialogue going. So it doesn't have to be just questions for us. You can pose questions. You can answer questions from within the audience as well. We're going to go through a few presentations, and then we'll save all of the discussion and conversation for afterwards. So the workshop that we had in Oxford was a 4-day workshop event with a 1-day conference where we brought together a number of participants from a really broad range of different backgrounds, both academic backgrounds or practitioner-type backgrounds, representation from many different parts of the world. And of course, there were people there at various career stages, right from grad student through to professors, as well as professionals in other sectors. And really important here is that everybody had a very diverse type of background. So not everybody was working in conservation. Not everybody was working in AI. People were working at a sort of intersection, I guess, of some of these different disciplines, or really in kind of tangential disciplines altogether. But everybody was curious about how we could approach this question of how can we apply AI in conservation. So we had identified 3 themes that we went after in our workshop. These were predicting conservation threats using social data to inform policy. Second one was about building foundation models for ecology. And the third one was ensuring equity and inclusion in AI use and application. And each of these groups produced a perspectives paper that is forthcoming. Hopefully within the next month or so, we'll have all of these out and available for all of you to read. So of course, these groups were quite large and diverse. Here's just a quick mention of all of the names of all of the different people who were involved. Of course, we can't give a proper shout out to each person, but this really was a huge team effort. And we're here as representatives of each of those teams. So we're going to have now a couple of presentations to give you a little bit of background or a little bit of an introduction to some of our conclusions within those 3 themes that we discussed at the workshop.
Hopefully everybody's not sleeping, because presentation after lunch is always it's a bit tough sometimes. But I want to talk a little bit about the group that actually discussed the use of social data in AI. So we call it reframing biodiversity conservation using social data in AI. Let's go over here. I think it's really important to bring the perspective that when we're discussing and trying to achieve common ground between all 17 members of the group while dealing with the matter of social data, we're thinking about how this social data could be incorporated in terms of conservation in general. It's really important to just start saying that every point of the biodiversity crisis passed through social aspects. I think we've been seeing in presentations here for the past few days a lot of social discussions and how this is important actually to tackle all of the problems linked to conservation in general. So that was our first point in our discussion. So one of the things we also thought is like social data already exists. We use a lot of different ecological data to create and to monitor indicators, but social data is over there, and we can use this and we can incorporate it and we can make it better decisions using this type of information. But before we start, like when we were in the workshop, we had to get this step back and discuss what were the types of social data we were going to look at. Because when we discussing the use of AI and how we can incorporate AI in different types of strategies, it's really important to keep in mind what we're discussing as social data. there's like quite a few types of different social data. This includes like behavior data, digital trace, economic data, even like values, attitudes, and also engagement that we can get from online data. So all of this bring a very difficult challenge while we're dealing this in an AI perspective, because when we're discussing social data, we're talking about very messy and unstructured type of data. So this also needed to be incorporated inside our discussions as a group. Once we passed to this part, we discussed a little bit the role of AI. I think here we've been seeing a lot of different examples of the use of AI in general. And in our case, we discussed from NPLs and machine learning and different types of use of AI. But I think the main point in our discussions were not really what you could do with AI, but how different sectors were using AI and how we can learn from that. So we thought about like the use of predicting models in the COVID-19 case, or forecasting armed conflicts, or even the application in illegal wildlife trade monitoring with AI. And then we came up with an attempt to include this perspective inside the conservation cycle, the planning cycle. So framing the problem, when we're talking about the use of AI, we're thinking about how we could use these tools to look at different data sets and maybe see a species that we're not seeing, or see some other aspects that we're not aware of. And this could help us actually to get in framing the problem. And also, while we're discussing monitoring the problem, we could just monitor the difference in prices or difference in other types of data and how it behaves online. While we discuss social data in general. And also addressing the problem just opened up for a very different strategies for using AI, for instance, like predicting reaction to different strategies for conservation or actions while planning, and all of this come together and all of this pass through social data. So that was our main point while discussing this in our group. Okay. But as we're also been seeing in this event, AI and the use of AI, it's very tricky. So there are a lot of different issues and problems we have to consider while we discuss this. Not like magic wands. It's not like magic solution for everything. Even for like looking at or thinking about large amounts of data or many possibilities for using it in actual conservation. We have problems related to consent and data sovereignty, scaling inequalities. We also have to think about the problem related to the black box systems, and they're very difficult to explain. How you actually approve different stakeholders, how you get to engage them inside like the use of technology. I've seen a couple of really good presentations that gave really good thoughts about how this could be done, but we're like in the beginning of this, so it's just really hard for us at this point to understand how we're going to engage this type of audience, how we're going to bring equity inside the game. So it's everything in the beginning at this point, and our group and in this opportunity we thought it was a really nice space for actually discussing it. Oh, okay. But in conclusion, I just want to add that from this, we could pass through the idea of not have as social data combined to AI from a reactive response to the problems while we discuss conservation, but to predict and to be proactive while we're dealing with these problems. Because we have the opportunity to use this information, we have the opportunity to understand how to use this information, and it's necessary for us to combine this with different tech and different professionals for us to get at this point. Also, I would like to thank ICTC for this opportunity and to have all these people here discussing such an important matter. It just shows how we are getting there somehow. Thank you so much. And fast to you.
Hello, good afternoon. My name is Michelle Kenyon, and I was part of the ethics group. So I'll be presenting some of the key. I'll be presenting an overview of the key challenges and opportunities we explored as it relates to ethics and AI. So why now? Well, we're here at the first international conference for technology and conservation. And we see AI is already reshaping conservation. We're seeing a massive shift where computational power is finally catching up with the scale of the biodiversity crisis. And like other sectors, the conservation sector is an early and eager adopter. We also see unprecedented constitutional momentum and investments. And this is fueling a massive expansion in the AI infrastructure. And this is positioning this sector to be a multi-trillion-dollar powerhouse pushing global transformation. And while we recognize the revolutionary potential for conservation with AI, we must also recognize that the speed of adoption has rapidly outstripped the creation of robust governance and ethical frameworks. So now we have this governance gap. And while there is a growing body of literature on ethics in conservation and ethics in conservation technology, as well as guidelines and review processes for practitioners and researchers, there are currently no comprehensive guidelines or reviews specific to AI and the use of AI in conservation, and it's important that we recognize this. What else is new? AI also introduces new challenges that conventional tech simply doesn't. For example, we're not just talking about privacy anymore. We're talking about things like algorithmic biases. We're dealing with like the black box problem where we can't fully explain the AI's logic or how it came to this conclusion. And importantly, we also face unintended consequences in the use of AI in conservation. For example, if we apply a predictive AI output to a real-world conservation strategy without local grounding, we risk making decisions that may not only be ineffective, but might actually be harmful to the communities and species we aim to protect. Our group focused on exploring three main areas in terms of AI and ethics. Before I go into those three areas, I wanted to touch on highlight two aspects. One, we can't talk about AI and ethics without talking about whose ethics are we using. So most AI guidelines are written by tech giants and Western academics. And we have this assumption that ethics are universal. But ethics are not universal. And if we apply these universal rules to for example, to a remote forest in Amazon or a village in Guyana, we risk a new form of digital colonization. We must also recognize that what feels ethical to Western academics and tech giants might feel like surveillance for a local community. So we have this core dilemma that creates a power imbalance. Who gets to decide what fair looks like? And then we also have this conflicting values and cultural differences. For example, we see a clash between technical efficiency and local autonomy. We see a clash or data openness, like global science versus data privacy, or indigenous synchronous perspectives. And I also wanted to touch on the risk AI poses to, the use of AI poses to people and communities. Technology is never neutral. If we aren't careful, AI could inadvertently silence the very communities, indigenous and local, who are recognized as the most effective stewards of our planet. And if we aren't careful, AI can deepen these global inequalities. So we may face this risk of digital marginalization where local knowledge is excluded from digital initiatives. And also, AI monitoring can breach the privacy of vulnerable groups. And we must ask, is this technology widening the gap between high-tech NGOs and local actors on the ground? These are just some things to think about in the use of AI in conservation. So our group looked at 3 main areas. We looked at our 3 key considerations: responsible model design and deployment, navigating the legal framework, and social equity and power dynamics. I must emphasize that as a group, we acknowledge that it is not possible for any individual or project to act perfectly ethically, as a lot of these ethical considerations overlap and conflict. Instead, we highlight the emerging trade-offs that must be negotiated early in project design and the responsibilities that we must bear to make informed, inclusive, and equitable decisions. So responsible model design and deployment. To ensure ethics, we must look at how we build and deploy our models. We must move beyond accuracy as the only metric, work towards prioritizing data sovereignty, for example, choosing hybrid models, refining pre-trained models with local data to balance technical efficiency with regional autonomy and relevance. Also, balancing the environmental cost, weigh the high energy and water consumption of AI deployment against less computational, expensive alternatives. Models must be explainable and audited. And we must also work towards ensuring reporting transparency, document the origin, limitations, and potential black box pathways of these deep learning models. Navigating the existing legal framework. The current laws are insufficient, and we cannot operate our models in a legal vacuum. Conservation AI is subject to a complex framework of land rights, privacy laws, and indigenous sovereignty. We acknowledge that the gold standard is free, prior, and informed consent. However, AI introduces a new challenge of informed consent. Can a community truly consent with when the technology is a black box? Furthermore, we face this irreversibility problem. Once data is ingested into an AI model, the right to withdraw consent becomes technically difficult or even impossible to honor. Also, we looked at data sovereignty and the risk of data sovereignty. We looked at data protection and data ownership. The power of AI is a double-edged sword. For example, AI can identify illegal behaviors such as, let's say, hunting or logging much faster than a human. But this triggers significant legal and ethical dilemmas. So for example, if your AI identifies illegal behavior in a data set, simply deleting might not be an option because this exposes you to legal liability. In terms of data ownership, this isn't just about copyright anymore. We examined traditional knowledge, and we also looked. A lot of countries now have laws protecting traditional knowledge, and some countries even have something called data localization, where your conservation data must be stored and processed within the physical borders of the country. So what's the takeaway? Don't wait for a lawsuit. Design compliance into your project from day one through early participatory engagement, while advocating for frameworks that protect biological data from private appropriation, while maintaining open science benefits. Social equity and power dynamics. We acknowledge that technology must be co-designed with local communities in order to avoid digital colonization. We often frame AI as a neutral technical solution, but it is deeply social. It enacts an ethical framework, usually the developers, often without debating whose ethics are being used. We explored ensuring, in projects, ensuring direct investments to lower digital divide, direct investments in terms of to communities, building capacity, and these direct investments provides transition from of providing access, which creates a customer, to providing ownership, which creates partnership. In our deliberations, we also looked at the 3 dimensions of equity. I'll just mention them really quickly. We looked at contextual equity, procedural equity, and distributive equity. Contextual equity asks for, if our training data reflects the community's reality or just simply ignores them. Procedural equity asks if we are giving local people a real voice or just tokenistic inputs. And we looked at distributive equity that tracks who gets the benefit, who gets the funding, and who gets the surveillance. So in our deliberations, we emphasized the need to ensure communities' rights to define and apply their own knowledge must be respected. And in conclusion, this is just an overview. I wanted to emphasize again that there is no perfect solution, only negotiated trade-offs. And the burden of making equitable decisions lies with us, the researchers and practitioners. And to be effective, AI in conservation must be transparent, legally robust, and socially just. Thank you.
Great. Thank you, Michelle. So the 3rd theme was about building ecology foundation models. And I was very lucky to be part of this group of really dynamic and exciting researchers. So essentially, our entire, I would say almost half of our first day was just about talking about what is a foundation model for ecology. What does this even mean? I think we can all pretty much agree that we understand maybe what a foundation model is, or at least kind of conceptually understand this term. These models are these really large, unsupervised or self-supervised models that are pre-trained using a really huge amount of data and computation. These models are sort of trained on a lot of data and then can then be adapted for many, many, many different types of downstream tasks. And adapting the model to different tasks and then actually using it, applying it to these tasks, requires substantially fewer resources than training task-specific models from scratch. So of course, the most widely known foundation models now are large language models like ChatGPT and others. We also have computer vision foundation models and Earth observation foundation models. And these models are absolutely changing the way that we do science and research across the board. So current foundation models, we would argue, these can be applied to conservation and ecology, but they do not in themselves represent an ecology foundation model. So for example, you can achieve species identification from images and, or audio or other data types. We can do species and behavior labeling as well using some of these models. even species distribution modeling, or understanding sort of relationships between species and the environment. And so models, for example, like taxobind, the last one that I have on the list here, this is sort of starting to lead us towards what we're talking about, where we're thinking not just about what is the species, how do we understand what's in the data that we collected, but actually how do we understand how the different components in the environment fit together. Yes, so they do not produce, these foundation models don't produce a representation of an ecological system. So what are we talking about here? Well, if we think about ecology, ecology is not the study of species, it's the study of interactions between species and between those species and their environment. So it's a study of interactions, really. Ecological data, of course, are spread across all possible scales of research, so right down from genes all the way out to environmental factors, and of course, they exist across space and time. So very complex, very highly multidimensional, and really, quite overwhelming to think about. So what we would like you to really consider when it comes to these ecological foundation models is that we need to have these interactions actually inbuilt in the system. Our vision for an eco-FM, or an ecological foundation model, is a unified, intelligent system for ecology that can integrate global data across all of these different scales, as well as space and time, within a single coherent modeling framework. So we propose one such framework that I'm not going to go into a huge amount of detail about right now, but one thing that's very important to us, or that we agreed was very important, is that we need to have uncertainty built into this model. So all data is collected with some degree of uncertainty, and if that is sort of thrown away at the beginning, then what results is a model that might be heavily biased in one direction or another, and we never have any idea about it. What's exciting about this kind of foundation model is that once it's been trained on obviously this massive amount of data that will have all kinds of challenges getting it together, it can then be used in a really huge variety of downstream tasks. So one of those tasks that is particularly exciting to me is the concept of using these graph representations of our data so that we can really hone in to those interactions both between species and their environment. And then we can do things like predict the effects of environmental change. We can model these no-analog communities, or these communities that we expect might exist in the future with global change, with the movement of species and the changing of climates. We can also determine keystone species and kind of gain a better understanding of what is really necessary in the ecosystem in order to make it thrive. So of course, these models could be used in a huge variety of tasks, not just for ecology, but also for conservation. And we also obviously had some discussions about the various considerations and risks, because these models do not come without, obviously, all of the inbuilt bias that already exists in the data that has been collected. So things like underrepresentation of taxa or labeling errors, these are going to be propagated through the data if they're not dealt with appropriately at an early stage. We could also identify a host of other potential risks, including things that have already been mentioned here today, like data colonialism, and of course the environmental risks, so the paradox of training a large model for ecological or conservation applications. But we believe that this sort of concept of train the really large model once and then be able to use it for downstream tasks with less computational power could be the way forward. So we think that ecology is really entering this phase where its central scientific challenge, which is explaining how species interact with each other and interact with the environment, and how these interactions give rise to the patterns of biodiversity, this aligns with a really major inflection point in artificial intelligence. And so with that, I'm going to pass it along now to Carolina, who's going to give some sort of summary remarks before we open up the discussion to you all.
I'll go to the podium.
Yeah.
But can I have the thing? Okay. Hi, everybody. Well, we have seen here, right, three different and complementary perspectives. Yuri, right, show us how social data and AI can track the human side of biodiversity so we can understand better the human drivers of changes. And Michel highlighted why ethics and equity must shape how we use these tools responsibly. And also Rachel just highlighted why, laid out a vision for ecological foundational models, right, that may even unify fragmented ecological data, and we can have like big amount of knowledge together. And I think together these three perspectives have a common agenda, and we agree on priorities. We need to be honest about risks, and also making the most of the opportunities if we do this well. I think the first opportunity here is, the first priority here is that we need to bring human explicitly into conservation models. Because we already saw that, and we all know, right, that biodiversity crisis is driven by human decisions and human behaviors. Yet the global monitoring still relies mainly in ecological indicators. But social data already exists and is underused, right? So our goal here should be to have systems that have ecological indicators, also social signals, and the management realities. And in that way, we will be able to anticipate problems instead of reacting when a species or ecosystem or communities are already in crisis. The second priority is to build an IA that is accountable for places and for people. Michel Wright showed us that there is no neutral AI. Every choice we made, like what kind of model we're going to use, or who is going to define what the success will be, embeds ethics. Even the best models can reproduce global power imbalance, right? So what we need, I think, is transparency about data and model limits. We also need clear governance on who is going to decide and who is responsible. And also, we really need meaningful participation of communities and practitioners from the beginning of our projects. The third priority is investing in infrastructure and capacity. We already have big amounts of data, right? A lot of ecological data, and also social data. But this data is scattered and is also even messy and hard to integrate. So a priority must be a long-term investment in data cleaning, standardization, metadata, right? And also in human capacity to use these tools in real conservation contexts. And only in that way, these models are really going to support for practitioners who translate models into action. Now, we also have to be aware of the main risks here. The first risk is scaling up existing inequalities, right? For example, if all the data come from the global north, of course, the better models and the better results will be where the power already is. The second risk is the loss of agency for local communities and practitioners, because we need a strong governance, and without a strong governance, all social data and AI can just be this can be finishing in top-down decisions, and with the justified as, no, the model said so, right? So that's very important. And the third is, well, our opaque system guiding high-risk decisions as black box models or hidden value choices, and also complex ecological model, maybe can creating like overconfidence in what we think and in what we decide. And we can end up treating outputs as if they were the objective truth. And that's never going to be, and there is always going to be uncertainty. So we need to be honest about risks when we use AI for conservation. And being honest is not pessimistic, right? It's part of the designing a better system. And that way we will it will bring better results. And well, despite the risk, there are also really powerful opportunities here. I think you all know, right? But we have to took those priorities seriously. The first opportunity we saw is that we can move from reactive conservation to anticipatory conservation. We need to combine social data with ecological models, right? And that can help us detect emerging conflicts or emerging traits. And we can also connect those data with habitat loss and climate trends or other environmental variables. The second opportunity here is designing interventions that are socially informed and more legitimate. AI can help us understand human attitudes and also policy dynamics, and if there are points of resistance or support to our projects. So that way we can co-design actions that respect local rights and values. And the third opportunity is we can build a shared ecological social memory, like for the planet. With AI, we can integrate so much data, right? From ecological studies, from community-based monitoring, from remote sensing and social indicators, and we can build like a very big base that we can use. Of course, it's going to be hard, right? But we can use to test different scenarios, and that way we can learn faster across different places. So now to really shape the future and not just react to it, I think that we need to prioritize integration of humans, ecology, and management, right? And treat accountability as a design requirement. We need to confront risks, especially around inequity and surveillance and opacity, and design safeguard before the deployment. And also take advantage of the opportunities together that we have. We need to change from reactive to anticipatory conservation. So we can design socially informed intervention, and we can build shared ecological and social knowledge between us. So as a final message, if we align powerful tools with ecological understanding, local knowledge, and a real commitment to justice, then AI can really become a partner in conservation. Thank you very much.
Great. So now is the part of the session where we would like to open things up for discussion. I'm very happy to take any initial comments, thoughts. One kind of stream that goes through the things that we've been talking about a little bit here today is this interplay between the benefits of using smaller models for bespoke tasks versus larger models that are obviously going to be very challenging to put together, but could achieve a lot of varied downstream tasks. So please, I'd love to open it up. Anybody who would like to ask a question to any of the speakers today or share your thoughts on this topic, we'd be very happy to hear from you.
Hi there. I don't know who would like to answer this, and I apologize if you spoke about it because I was a little bit late. But as a technologist myself, I'm very much intrigued and grateful for where AI is going. But one of the biggest risks is the energy consumption. And I feel like we've talked a lot about what we want to do with AI and all the great things it can do for us, but I haven't really heard anybody yet address this. And so I just want to know if this came up in your workshop and how you guys feel about it, because we don't really know the direct impacts of this yet, right? So yeah, I'll just leave it there and see if you guys have any thoughts.
Great, thank you. Would anybody like to take this one from the panel?
Well, I was in the ethics group, and we addressed that topic. I mean, we don't have an answer because I think no one has, but we talk about it, and we think that it's a very big problem, and that's part of how we do our job more efficient, right? And not just I think it's important how to say it. It's just not using AI because it is available, right? And just use it because when you really need it. In the ethics group, we talk about when you are going to do a conservation project, we you need to ask a question. And the first question was, do I need to use AI? So I think that is something that we have to ask ourselves, and not just because it sounds like a fashion or a very shiny thing, but I think we need to use it when it's really necessary. And I mean, it's not going to solve the problem, but maybe it's like the beginning of something, but it's very difficult to get to that answer, right?
Yeah, this also came up in the ecology foundation model group quite a lot, because obviously foundation models are incredibly computationally expensive to use. I think the idea here is not to just throw AI at problems that are already being solved in different ways, using a bigger model and somehow hoping that it'll be done better, but actually applying AI in a way that is going to help us to achieve our goals, or help us to be able to understand the ecological systems that we're dealing with in a way that we can't yet, because we are not actually integrating all of the data that exists, and we're not able to make these connections. So it's going from, yes, okay, species identification, obviously very important, to something more about understanding what is it that's shaping that ecosystem, and what happens if we take away a species, or if we plant a monoculture cropland in a particular area. How do we predict what's going to actually happen? So how do we make these management decisions if we don't have a way of actually modeling these impacts? So I think that's kind of where it was for us, where it's like, yes, obviously these are not going to be models that are super cheery for the environment, but can we really afford not to take this step at this time? Yes, anyone from?
Well, first of all, thank you very much. This was very useful and interesting. And I wanted to ask you, presenting you my personal case, like, I don't want to overlook like an ethical conflict in what I'm doing, but I can't seem to see what can I be doing for this. And my case is, for instance, I'm using BirdNet to train a detector for frogs, like just to analyze big and huge data sets of passive acoustic monitoring. How could that be doing something unethical in this particular case? Like, the ethical problem is when you use models to analyze data that, like, directly data from people, or maybe where the company or the institution that built the model may be incurring or something that I don't know if you understand my question. Is like, how can I overlook, or what do I have to pay attention?
So your question is about what ethical issues should you be concerned with
Yes,
your data
yes.
and choice of model?
Yes, in this initial state, like, since I'm not using for the moment like that data from people, just monitoring frog populations.
Great question. Either of you from the ethics team want to take this one? Michelle? Or
Okay,
Carolina?
I can go. Yes. Well, a big discussion we had, it was with the audio recording and the AI processing it, and well, first, I think we get into the conclusion that the ethical issues will be very context dependent, right? First, like, for example, you're recording noises and you can hear people, right? And what are you going to do with those recordings? And also, if maybe people are going to know that you are going to be recording noises where they are. I don't know. Well, of course, it depends on the context, but we think that you have to be aware of which is like the ethical issue in that place. Like, for example, is there illegal trade or something you can detect with the recordings? And well, maybe if not, and it's like, no, I'm recording frogs in, I don't know, in somewhere where there is no people, then it will be easier So it depends really on the context, but it's something that you need to ask like at the beginning of the before you are going to start the recordings, right? So I think something like that we were talking about. I don't know, Michelle, you want to add something?
Hello? Yes. Just to back up Carolina here, so it's the context is really important. Planning in advance, like designing, when you design your project, are there people there? What's the legal framework in the country? So do you have obligation to government to pass on things that you capture? Because you're in this position where you can't just delete other things, noises. So just having these questions in advance and planning in advance of how you want to tackle these issues as you come off. As I mentioned, a lot of it is negotiating trade-offs and how you navigate this space of ethics in AI.
Thank you.
Thank you. I think there was a question also just behind you, and this might have to be our last one.
Oh, no pressure. Yeah, thanks. I agreed. Thanks for that. Super interesting. I took a ton of points. I'm not a technologist, although I was told yesterday I shouldn't use that word. So I learned a lot. I guess my question is, Carolina, based on kind of where you ended, my basic question is like, what is the strategy for proactive conservation? What does that look like? Because most of our strategies respond to trends in population numbers and deforestation and things like that, which I get, that's reactive, that makes sense. So if that's not proactive, what does it look like in the future if we are pursuing that? And then like a sub-question, how do we mobilize resources for things that are predictive and well modeled based on a ton of data, but still a little speculative?
Go ahead.
Okay. We have long discussions about that because I think one of the main things in the social data group were how to come from this place where it's like we're reacting to everything to actually starting thinking about it and using these models to try to predict something. We're more linked to the ideas where we could see it happening in different fields, I guess, which is not what we've been doing in conservation in many cases. Like if we can build a model, or if we can view a tendency, or if we can understand where a conflict will happen based on the data set. For instance, like we discuss a lot with human and wildlife conflicts. So if we could see trends in data in a place or a situation, or you can see potential danger happening there. So you could come with this large data sets, with this large amount of information, and just have these insights before it happened. So our main point there was like, once you can see it, you can plan for it, and start like getting some kind of like preparation before it happens. So I guess this was the main point there. And sorry, I forgot the second point that you raised. Sorry. Yeah. I think it's very tricky, like, because we're the point in the group and in all the groups as well, like, because of the people who were discussing the use of AI, was that we still understanding how we're gonna do this. It's like it's in the beginning, like we're understanding how the models were created. You open your computer every day, and there are like 30 different models created, like 30 different AI, different that you could use for a different purpose. So for us, I think it's now we are understanding what we can do from that, and then we're creating what would be like funding, what would be like how we can mobilize resources and everything for actually working with that. So I don't see we in these stages, but like we're gonna be there somewhere in the road.
Great. Okay, this is all the time that we have. I do just kind of want to finish it up by just saying I really, through this process of interacting with this really broad group of people, I have learned so much, and also at this conference, interacting with all of you. I just want to encourage you all to keep your perspectives broad. I spend a lot of time thinking about how to get my model working, and why am I not getting it to but I'm not thinking maybe about, oh, maybe I should be more considerate when I'm collecting data, or who is this going to impact? So just, I encourage you all to keep your net as broad as possible when it comes to some of these issues. And I'm very optimistic about the future of this, of AI for conservation. Thank you.